In my previous video, we built this whole parallel 4-link back suspension from scratch, and I think it's looking quite good, but I couldn't quite finish it up because I still needed to set the pinion angle before welding on my brackets for final. So I asked Wayne and Matthew to quickly help me take the cab off and drop the engine back into place. So now I can measure my engine angle, then set up the pinion angle of the back axle or differential, and then I can finish it up. We can test it to see how it works and take it from there. Coming up. So with my engine and gearbox or transmission now bolted into place, I can put my angle finder here on the output shaft to measure that angle. Right, so with my angle finder on that flange, I get a measurement of 4.2 degrees. And so let's keep in mind that this is relative to the horizon, not relative to my frame, which I didn't check to see if it sits level, but I really don't care.
So this dude said some things I like so much. I've even got a painting of him up in my shop. So one of those things he said is very relevant to what we are doing at the moment. He said, everything is relative to reference.
If I zero this, and now I go and put my angle finder on the output shaft of the diff, set it up to also be zero, then I will know that the output angle on my transmission will be the same as the input angle on my differential, and that's what we want. So I've got these temporary sort of cradle contraptions in place on both sides, so that will actually allow me to rotate my rear axle while still keeping it in position. So if I stick my angle finder on here and rotate my diff until I've got the same angle as the output shaft on the transmission, then I'll be good. So I've still got that zero setting on my angle finder, so I need to rotate this until we get to a little bit more up, until we get to zero as well. Almost. I think we're there. Yes. So this is effectively what we've done now. A picture is always nice to understand things. Effectively, the center line through the transmission is now parallel to the center line through the rear axle or the differential, which is the same as angle A, which is the angle between that center line and horizon, is now the same as angle B, which is also the angle between horizon and the center line through the transmission. So now I'm sure some of you are going to say, but the differential or the rear axle should be at right height to do this. Currently I've got my diff fully slammed, so there's quite a bit of movement that's going to take place here, but it's not necessary. Let's go to the forest engineering design office, and I would like to show you something regarding this. So what's going on here then? I'm using the world famous forest engineering pad system to simulate my parallel 4-link, so we can get some insight into the geometry. If you didn't know, PAD stands for Plywood Assisted Design. So we're looking at it from the side, obviously. Here's my upper link bar, here's my lower link bar. Important that these distances from here to here is exactly the same on these two link bars. And also important that this distance apart in the front and in the back is exactly the same, hence a parallel 4-link. This here represents my rear axle or my differential, and I've just added this bar here to represent the center line, or then for that matter the pinion angle. So let's start by just drawing a line here. Now I'm going to move it up a little bit, draw another line. Let's go up a little bit more, and why don't we go down some as well. And I think you can see that no matter where we go through the travel range, those lines remain parallel to each other. So it actually doesn't matter whether my back axle sits there or down here, pinion angle remains the same. So on an air ride, this might be my ride. I might be up here somewhere when I'm slammed. But the big advantage of using a parallel forelink on an air ride is no matter what ride height I choose, I could be down here or there, the pinion angle remains the same. In my opinion, this is the only forelink system to use on an air ride where we've got a lot of suspension travel. Some forelink setups will have this kind of scenario where the bars are not parallel to each other. Let's see what's going to happen with the pinion angle. If we're down here, we're parallel to that line, but look what happens as we move. The pinion angle changes. So I really don't think this kind of setup will work for air ride. If we want to have different ride heights, the cars that do use this setup will typically have very little suspension movement, so then it doesn't really matter. Excuse me. Here's another setup you will see on some cars where the bars are not the same length and they're not parallel to each other. Let's have a look and see what will happen to that pinion angle when we have this setup. I think it's quite clear. You can see how that pinion angle changes as well as we go through motion. So again, in my mind, not the answer for an air ride system where you want to be able to ride at different ride heights. It all depends on application. But these kind of scenarios where your link bars are not parallel to each other, there's stuff like instant centers. If you project this line forward and this line forward, they meet at the point. And then that's related to center of gravity and all sorts of stuff that we're not going to get into. But in my mind, with air ride, primary consideration is that my pinion angle remains the same throughout the travel range. Also, with this kind of setup, your range of travel is typically very little, and then you don't have much of a pinion angle change. And other factors like that instant center business is more important. Like I said before, it all depends on application. Okay, enough theory. Let's get to doing some work. So I've double checked my pinion angle here to make sure that it is the same as my engine angle. And then I've clamped my back axle right here. So now it's locked up, it can't rotate anymore. And I know my pinion angle is good. So the back bracket here is not welded on yet, since I first had to set my pinion angle. So the next step for me then is to measure up so that I can have this sitting in the correct spot, and then I can finally weld it. So I'm going to measure this distance. If I can get my tape measure to hook on that side, there we go. And then I want to have the same distance here. Make sure everything is nice and square. Doesn't look too bad. So then I'm also measuring the distance between the flange here and my bracket. I want to make sure that it's the same on both sides.
one more thing I want to check, and that is to make sure that my bracket is square to the axle. I think that looks good. Right, so this distance is the same on both sides. The distance from here across to the same point on the other side is the same as what I have in the front. I set my pinion angle, this rotation is now set up. So there's only one thing left to do now, and that's to weld on this bracket, and the same with the one on the other side. I've double checked everything again. Let's weld on these brackets. Right, so my brackets are not fully welded, but there's enough welding to make it work for now. I mean, I'm going to have to take this back axle out anyway to paint it, so I struggle with outside welds right now. So I want to take out these temporary braces, this one and these. I installed this cross brace just tacked in for now. I don't think that's where it's going to be sitting finally. Probably have to move it more this way. And that'll provide a support for my shocks. I still need to build the brackets for that. But I've just got it in for now to brace things a little bit. So let's take out all these temporary braces. Okay, let's see. It's working. It's going up and down, if nothing else. So let's have a look at this business a little bit more. Look at this. Those heim joints allow a lot of this sort of diagonal movement. You would never get that much if you used bushes. The problem at the moment is this. You can see there's nothing holding this back axle from moving sideways. So there's typically two solutions to that. Either a pan-out bar or a Watts link. And I think that's what I'm going to build. I'm going to do a Watts link to keep my back axle nice and central and to avoid sideways movement. Okay, well, if I want to build a Watts link, I need some bits and pieces that I haven't got. So I'm going to have to haul my ass off to town to go and find those bits and pieces. I need 4 heim joints and some other things, bolts, nuts, etc. So I'm afraid this is going to be quite a short video, but at least we got the back end to go up and down
and the forelink is pretty much together. So I'm happy with that. Thanks for hanging out with me out here in the forest. I enjoyed your company. I'll see you in the next video when we carry on with this business. Have a lucky one.